cosine of
Oh, we
pi over
discussed
4
this last
equals-
time, that sine and cosine of pi over 4, they're the square root of 2 over 2. We had the table.
Oh, okay.
This is the 45-degree angle, and that was discussed last time with a little table.
Okay, thank you.
Thank you. Good. Other questions?
I have one more.
Yes, please.
So for the final answer, it has to be the square root of 2 over 2, right?
Yes.
Okay. Okay.
Yes. Good. Other questions? Thank you for asking questions, because otherwise I don't know if anyone is following. And it's very important to me. Okay. Good. So the next section deals with quick graphs. So let me make sure that I did not miss anything. I'm just looking at these handouts. I think find the exact value. We know how to do that. We did an example like that. And I guess, okay, this is done. The unit circle 5.5, just making sure. Yes, we look at the properties. We look at all of those. Okay, this is done. So now let's quickly look at 5.6 with, yes, that's what we're doing next. Graphing sine and cosine. We started with an example a few minutes ago, but let's go back. So this is finally 5.6. The graphs of sine and cosine. So graphs of sine and cosine, I want you to remember from the unit circle, this is another very important property of sine and cosine. So this is the unit circle, first quadrant, second, third, and fourth. So now we call these functions bounded. What does it mean, bounded? It means that sine as well as cosine have a lower bound. They cannot go lower than this. And they have an upper bound. They cannot go higher than this. Can anyone tell us by looking at the unit circle? And remember, cosine is measured here, sine is measured here. What is the smallest possible value for sine and cosine? Identify these.
0.
Identify these points and their coordinates, and you will know the minimum and the maximum possible.
Is it -1, +1?
Excellent. So these are the only bounded functions like that, sine and cosine. They also have, as we know, so sine, cosine have amplitude. They also have period that we know. They also have something, a horizontal shift. It's called, for trig functions, it's called phase shift. Okay. So when we graph sine and cosine, we will always find these elements. So let's look at an example. Let me graph the functions, pure functions first. We already did the sine. So here is the pure function. So of course, this is +1 and -1. It cannot go below -1. It cannot go above +1. So this is the graph of sine. First quadrant, second quadrant, positive. Third quadrant, fourth quadrant, negative. And they repeat as indefinitely. So this is the graph of sine. But let's also graph cosine. So the graph of cosine looks like this. Of course, -1 and 1. Of course, pi over 2 pi, 3 pi over 2, and 2 pi. It looks like a vase. It looks like a vase. because it starts at 0 where it's 1, right here, it 0, then -1 as we know, then 0, and then +1. So as I said, it looks kind of like a vase. So this is cosine x, pure, no transformations. Amplitude means half of the distance between the low and the high. So this distance is 2, so amplitude is 1. So in this case, the amplitude is 1. It's the number in front of cosine. The period for this function, we already know, is 2 pi. The phase shift, nothing, 0. It's not shifted anywhere. Okay. So back to the handout. Let's take a look at what happens and what is the form of these functions when they do have transformations on them. Okay. So,
Could you,
yes?
sorry, could you go to the page where you have the graph of sine?
Yes.
please? Look for a second.
Yes. Yes.
All right, thank you.
Thank you. Okay, so what if we have something like, this is the generic situation, A sine omega x minus phi, or y equals A cosine omega x minus phi. So this symbol is omega. This symbol is phi. They are Greek letters. Omega and phi. Okay, what's this? Well, we can be given, and I'm just going to start with this problem and then we'll choose others. So we may be given something like this. Y equals 3 sine 3x minus pi. And the question is asking us, find the amplitude, the period, and the phase shift. Eventually graph the function. Okay. So this is a different story. Pi sine x has period 2 pi. But this is not sine x. It has all sorts of transformations and a shift. Left, right, it's a right shift. And it has an amplitude, and so on and so forth. So here the amplitude is 1, the phase shift is 0. But this is not the case here. It's not a pure function. It has complicated stuff in it. Okay, so first of all, the amplitude, because it's a distance, it's half the distance, always half the distance between max and min. So this is 1 unit, this is another unit. 2 units divided by 2, the amplitude is 1. Here, the amplitude is this number in front of sine, so the amplitude is always a positive number. There is no need to put the absolute value. I just want to remind you that whatever you have to put the absolute value on it to identify the amplitude. So this is 3. What does it mean? It means that it goes up to 3 and down to -3. Now, I'm going to delete this. But what if I have here +4? It's a different story. So it's 3 plus 4, it goes to 7, and then to 3. Because the whole thing is shifted up 4 units. So I'm going to delete that, because right now there is no vertical shift in this function. So therefore, we will analyze the amplitude, the period, and the phase shift. The amplitude is clear. It will go up to 3, down to -3. Now, we have to factor out 3, but not before we find the period. The formula for the period is, because it's sine, I have 2 pi over omega. This is my omega, is the number in front of x. So 2 pi over omega will give us 2 pi divided by 3, which means that this function will repeat in chunks of 2 pi over 3. Not the big chunk of 2 pi, but smaller, much smaller. So instead of being like this, between 0 and 2 pi, will be like this, potentially, many times. How many times? Well, it's 2 times 60, which is 120. So 3 times. So 3 complete periods will be in 0 to 2 pi. So something like this. 1, 2, and 3. Of course, it's not a nice graph. I'm gonna show you how to graph it in a minute. So it repeats itself instead of 2 pi in chunks. So three complete chunks in 0 to 2 pi, because that's what it is. Okay. Now I have to factor out 3. You cannot take it out in front of sine. You can take it in front of the parentheses. So we have y equals 3 sine 3 x minus pi over 3. Okay, what does this mean? 3 times x is 3x. 3 times negative pi over 3, I simplify and I get the pi back. This is what I need to identify the phase shift. Notice the negative. So the phase shift, which is phi, is pi over 3, of course, to the right. So we identify the amplitude, we identify the period, and we identify the phase shift. Okay, so let's graph this and see how it works. So in y equals, clear whatever you have. And punch it in. It doesn't matter if you punch it in as the original function or factored out. So there was sine, and in parentheses we had 3x minus pi. Okay. Now, before I continue, I have to explain, because we have to choose the viewing window. So the viewing window in the graphing calculator has to go up to 3 and down to -3 for sure, because that's the amplitude. And there is no vertical shift. Now, the period is 2 pi. The phase shift is at pi over 3. So how do I choose the viewing window to see exactly the function that I want? I will have to start at pi over 3. I will have to add, so my pi over 3 will be right here at the beginning. So I have the pi over 3. That's my starting point. Then I have to add to pi over 3. I have to add the period, so I know where to end. So 2 pi over 3 plus pi over 3 is pi. So if I have the viewing window between pi over 3 and pi, I will see a complete rotation, 1 period of this function, 3 sine 3x minus pi, going from -3 to +3, a complete sine. Let's see if that's the case. Okay, so the viewing window, make sure that your calculator is in radian mode. So the viewing window, I want to start at pi over 3. I don't want to go beyond pi. I want a scale of pi over 4 or pi over 2, whatever you want. I want pi over 4. The scale meaning the tick, right? Tick, 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 tick. Okay. Y minimum, I don't need more than -3. Y maximum, I don't want to see more than 3. Well, let's see what happens. And I will click graph. Exactly as I expected. It gave us exactly a complete rotation or a full period of this function. We started a phase shift pi over 3 to the right because it was negative pi over 3, as we know from transformations. And it ended by adding to the phase shift a full period, which was 2 pi over 3. So pi over 3 plus 2 pi over 3 ended exactly at pi, as expected. Any questions? Any questions, please? So of course, you understand what I graphed here, but this is not a graph. Now, you can present more than one complete rotation or one period. How? By adding 2 pi, adding 2 pi over 3. So if to 2 pi, if I add 2 pi over 3, I have 3, so this is 5 pi over 3. And if I end the graph, instead of going to pi, let's say I want to go to 5 pi over 3, I should see 2 complete periods, the same thing twice. Okay, what did I do? Ah, okay. I changed something else. I changed the scale instead of changing the max. Okay, 5, sorry, one more time. Okay, 5 pi over 3. Now I click graph, I have to see 2 identical. Perfect. So this is one, and this is the second one. Any questions? Any questions on this? So this was sine of 3 pi minus, and so on and so forth. Let's look at another one. Would you like to choose, or you want me to choose the next one? That is a cosine. Is that okay?
Yeah.
Okay. So y equals -2 cosine 2x minus pi over 2. Can anyone give us the amplitude for this function? Please.
-2.
Careful. In absolute value. Excellent. What is it?
2.
Yes. So it is 2, meaning it cannot go beyond 2. It cannot go below -2. Okay, perfect. Can anyone give us the period? How do I calculate the period? Remember, it's cosine. So it is 2 pi divided by omega. So the period is pi. So this function does not repeat in chunks of 2 pi, but in chunks of pi. Pi, pi, pi. Perfect. Now I have to factor out 2. Can anyone tell us what to write in parentheses after we factor out 2? Because now we need to identify the phase shift, phi. How do I do this? Anyone, please?
Would it be x minus pi?
x minus, if I write pi, when I multiply pi by 2, I will not get pi over 2. So I can write pi. Now let's check. 2 times x is 2x, but 2 times pi is not pi over 2.
Or
Thank you. Let's check now again. Thank you. 2 times x, 2x. 2 times negative pi over 4. When we simplify, we get indeed negative pi over 2. Awesome. So then phi, because it's minus. Now let me change this and I'll correct it. If it's positive, then phi will be negative pi over 4. Please remember, like with the previous transformations on other functions. But we have minus pi over 4, which means that phi is positive pi over 4. Good. Awesome. So let's graph it. Sorry, of course. We have to discuss the viewing window, so we know what to put in. It's negative pi over 4, so I can start here at pi over 4. It cannot go more than 2, and it cannot go lower than negative 2, absolutely clear. And because we start at pi over 4 and we add pi, because I want to see the entire graph, and I'm adding pi to pi over 4, so pi plus pi over 4 is 5 pi over 4. Between this and this, I should see a complete rotation, okay, a complete period. Remember, it's negative. So remember the graph of cosine. It's like a vase. But because it has a minus in front, it will flip. So it will look the opposite. So it will look something like this. Because it has a negative leading coefficient. And I shouldn't say negative coefficient, but a negative number in front. So it has to be flipped. It's negative. It's a reflection. So this is what we should expect. Okay,